Okay, so here's the reaction we looked at last time. This is the burning of methane and thinking about the energy that goes in. So if you filled out this chart correctly, these are the numbers that I got. So we have two of these bonds, two of the O2 bonds here. This one here, this one here. That's equaled 996 kilojoules. And the CH bonds, 413 times 4, so we have 1, 2, 3, 4 bonds. That equals 1652. So we add that together, we get a total of 2648. Okay, so this is, the numbers aren't super important, just kind of thinking about how much energy is going into these things. When I break it apart, I put in 2,648 kilojoules of energy to break these bonds apart, and now I have all these atoms kind of flying around. But they're not stable. They don't want to be like this. You remember we started at the bottom? The bottom of the energy diagram, the well, is where they're nice and balanced. All the things are balanced, and now we break them apart. Now we put in a lot of energy. So then we move to this. So the bonds are broken. The atoms are flying all around. What was this? Let's look. Okay, so, and now they snap back together, but they form new things. In a chemical reaction, we form new things. And so now we have water, and we have carbon dioxide, and we formed these two OH, so 4 OH bonds. So here, 1, 2, 3, 4. That's 1868 kilojoules. And then this carbon dioxide, CO, it's a double bond. We have two of these, one here, one here. That's 1490. So we add that up, and that's 3,358. That is a bigger amount than the other one. So remember, previously we had 2,648. This one, 3,358. So just the actual numbers don't matter so much, except just how big the numbers are. The first number, energy going in, it's kind of small. Energy coming out, much bigger. Okay, so what does that look like in terms of an energy diagram? Well, now we have, we've got energy in, 2,648, so that goes up like this. But the energy out is much bigger, and so this is what this type of energy diagram looks like. We have this big drop right here, this giant drop of energy, okay? And so more energy is coming out, and so this is what we call an energy diagram, or reaction energy diagram. And so here's the question. The first question we're going to have is, I have a new arrow. And so if I start at 0 here, this is my dashed line and show me where 0 is. This new arrow here, what do you think this new arrow kind of represents in this energy diagram? So I have energy in, energy out. What does that represent? I don't need a number. Just like what do you think about in terms of how it's what is it showing? What is it trying to show? Another way to think about this is, instead of energy, if you don't think energy is kind of hard to think about, maybe think about money, okay? So if I have $2,648, I put it in, let's say I give somebody $2,648, and then they have to immediately give me back $3,358. Well, what does that mean in terms of that person's money? How is that represented with this arrow? Okay, so think about that. That's going to be your first question. One of your questions you're going to have to answer. And then, as we talked about, we have these other reactions. So remember, this reaction was burning methane. Burning here, like this. Burning a candle has the same type of diagram. I have energy in, energy out. Burning ethanol, same type of diagram, okay? What do these all have in common? what do these reactions all have in common? And then, are all energy diagrams shaped like the ones we just saw here? Like this kind of shape. Go up like this, coming down like this. And so we're going to do a chemical reaction now. It's a little experiment you can actually do in your kitchen. And yeah, you can do a reaction in your kitchen. Get a thermometer, get some vinegar, some baking soda, and we'll see you in the kitchen in just a second.
Hey, welcome back. So here's our question now. We are at a point where we looked at all these other reactions, and they are flames. We have energy, and we can feel the heat coming out of them. And the question now is, are all energy diagrams going to be the same way? So I have another reaction that you can try at home. This is one that a lot of you have done probably in middle school, but it involves some vinegar. Okay, so you need some vinegar, which is an acid. It reacts with baking soda. Baking soda is, it has some bubbles it gets from it. So, and you also need a kitchen thermometer. So I have some vinegar in here right now. It's just a tall glass. Oh, that's my pie crust. I need to take it out of the oven. Just give me a second. All right, there we go. It's to celebrate all the warblers we found. Oh, I gotta turn the oven off. So to celebrate all the warblers we found, I made something like a warbler pie. It's not, you don't use warblers in the pie, but you celebrate the warblers because they had this place where they somewhere, McGee Marsh, yeah. So McGee Marsh, they had this restaurant nearby, and people go there all the time. They're looking for warblers, and when people, the celebration is if you find a new warbler, you can go buy some warbler pie and celebrate. So I'm making a pie because we found so many new warblers this past week. Even in our backyard, we found a bay-breasted warbler and a blue-winged warbler, and I'll share some pictures with you later. So anyways, back to science. We have vinegar, which is an acid, and right now you can see it's reading at 65.8 degrees Fahrenheit. Okay, and the question now is, when I mix these two together, what's going to happen to the energy? What's happening to energy as we have this chemical reaction? And how is the energy diagram going to look? So I'm going to take some baking soda here, and I'm just going to go ahead, 65.8. I'm going to go ahead and just dump it in. Okay, and so it's reacting. And what's happening to the energy? What's happening to the temperature right now? You can see, whoa, look at that. Dropping down very fast. Okay, so it got all the way down to about 57 degrees Fahrenheit. And it's like leveling out now, about 58.5. But what does that mean in terms of the energy diagram? Do I have more energy going in? Because remember, we break bonds, we got to put energy in, but we also make new bonds that releases energy. What is happening now when that temperature is dropping like this? I forgot to do this as a point of reference. So remember, our first reactions were lighting a candle or lighting a flame. And if I have this thing here, so if I look at the thermometer, it's like 62, and I take the flame and I put it by the here, right? We know that that temperature really goes up. This is the flame. So that temperature is going up. That is the energy diagram when I put in some energy and I release a lot of energy. And now we're thinking about what's happening when I have something where the temperature goes down.
Okay, so the final question we have is, does our energy diagram of the last reaction, match the same as the one that we have burning stuff, or does it look different? So I want you to think back to what we did with these three arrows. I know that we're not quite sure what these arrows mean, but we know one of them is breaking bonds. I put in energy to break bonds. I release energy when I make new bonds. I put in energy to break them, and then when they snap back together, I release energy, and then I can feel some heat overall. So maybe one of these is how the heat I feel with my hands or with the thermometer. And so there's this overall energy that's happening here. One of these arrows is like this. So if I have a reaction where something is burning, we know it looks like this. However, if I have something where it's cooling down, where its energy it's feeling different. I put my hands on it, it gets colder. I can put my thermometer on it, the temperature drops. Is that something different? So does it look like this, or does it look something like this? So this is another way that you can have an energy diagram. Here I want you to also describe what is the energy going in, which one is the energy going in, where is the energy, which arrow shows the energy coming out, and then overall, what is happening to the energy here, and why might this one help us explain why the temperature is going down? So think about that, these two energy diagrams, and then we'll kind of wrap this all up the next lesson.